is part of our new protocol that we're going to be talking about before we talk about it. Before we talk about it, we're going to demonstrate it. So you'll be looking at my teacher actions as Mr. Gerke, the wannabe math teacher, and then the impact on student learning. So you'll be tracking those as we go. We're actually going to go ahead and get this lesson started now. We have about 2 minutes left, and I'm looking at my students here as they're completing these first 2 questions. Thanks for coming prepared, Mr. Haslett. This year. Wonderful. Thank you. These are complete sentences. Good to see. All right, I'll give about 1 minute to finish the first 2 questions. Make sure you answer the first one in complete sentences. And the second one, just try your best. I'm not expecting you to know any of this, but just try your best. Oh, excellent. Wonderful. All right, y'all have about 5 seconds left. All right, so our objectives for today. Today I will use inquiry and collaboration through partner practice using real-world scenarios. So I can solve for an ordered pair in systems of equations using substitution. I know I have one I can solve for an ordered pair by myself via question number 4, showing my work. That is the second number 4. I'm notorious for putting multiple numbers of the same number. That is the last number 4 on the back. That'll be our assessment of this lesson. But before we jump into any of that, let's talk about some of the responses you have to the first question. And for the purposes of this, I'll pass the mic around for our folks on the stage. But just as you all know, I like to call randomly because everyone's voice matters here in this classroom, here in Algebra 1. We are changing problems through math, changing the world, finding solutions to the world's problems. So I appreciate you all taking time to answer the first one. So I'll be calling on, let's hear from Aaron Vaya. What did you do for the first question, sir?
I did, I don't know what some math, but I did steps or items that could lead you to an end goal.
Awesome. Let's get Aaron some stats. Everybody, stats for Aaron. Thank you so much. Let's hear from Henny. Go ahead, Henny.
I wrote a series of steps that you must follow in order to get to your answer in a specific order following the steps.
Can you think of an example in your life of where you've heard the word system before?
System. The steps in order to bake a cake.
Okay, so like you have a system for making a cake.
Right.
You know how to make good cakes?
I do.
What's your favorite kind of cake to make?
Orange sponge cake.
Oh, orange sponge cake. Snaps for Henny on her orange sponge cake. Who else can think of an example of a time you've heard the word system used in your everyday life or your real life? Go ahead, Derek.
Sports.
How do you see systems in sports?
Usually when you have a coach, they have a system of how they want things to function. You have to follow those steps to be in compliance with the system.
What's the difference between a coach that has good systems versus a coach that has not so good systems?
Wins and losses.
True. But without that, as you see the systems happening, what would you say is like, man, can you observe like that's a good system in the process?
Yeah, well, the steps are specific,
Okay.
and they're something that you can follow and measure success at each step. Also, good system.
Now, so Derek, can anyone think of any non-examples of systems? What do you guys think would be the opposite of the word system? Any thoughts? Go ahead, Eric.
I think the opposite of the system would be chaos,
Yeah.
free-for-all, anarchy.
Awesome. Snaps for Aaron, please. Excellent. So the smoother the system, the clearer things are, and the opposite could be considered chaos. I would definitely agree with you there. So if you have something like that, that's great. If not, go ahead and take down a couple of details there. One example I had when I think about video game systems. So, you know, like a PlayStation 5. Some people are very passionate about getting their hands on PlayStation 5 systems. A system is when two or more parts work together to form a whole. So in that PlayStation 5, you might have the controller, the TV, the hard drive, the Wi-Fi, everything works together to create that system. And that is what systems of equations are all about as well. Up until this point, we've only looked at linear equations here in Algebra 1, and that's been fun. You've got one input, one output, they make straight lines, we talked about functions. Is this a function, is this not a function? We talked about the vertical line test. But what do you do when there is not necessarily a clear, what do you do when there's more than one variable? And so when we get to more than one variable, that's what we're talking about, systems of equations. Can we please make sure that our phones are put away in the cell phone holder, please? I appreciate that very much. Thank you so much. I love yeah, Mr. Ramos? No, she gave it up early, willingly. I appreciate it. You did that? Okay. All right, question number 2. Consider the following situation. Can you figure it out? I already gave you guys time to think about this answer. Does anyone have any quick ideas real quick about how you would have solved for this first one right here? Any thoughts on question number 2? I'll get back to you in a second, Derek. I appreciate you participate already. Go ahead, Alicia.
So I think probably I would work backwards. I would take a look at that there were total 97 points, and then I would give the information that they said that there was 11 3 points, and I would know that that was 33 points. So then working backwards, I would say 97 minus those 33 would leave me with just 64, and then I would figure out how many 2-point shots would make those 64 points.
Oh, nice. You kind of like backwards checked.
Yeah, like begin with the end in mind.
Yeah.
And come back.
Definitely. Did you use equations at all? Did you use any variables, x's, y's, anything like that?
No.
Okay. All right. Derek, was your snaps for Alicia, please? Derek, was your solution similar or different to Alicia's?
It was actually the same. I just looked
Okay.
at it.
Okay. If we were to make these into variables, did anyone do it that way? Did anyone use variables to solve this? Like x's, y's? Go ahead, Mike. Can you explain how you did that, please?
Yeah, I set mine up and I put X as my 3-point and then Y as my 2-point baskets.
Okay.
So I multiplied my 3-point baskets X by 3, and I multiplied my 2-point baskets by 2. So I had 3X plus 3Y.
Can you
No,
tell
3X plus 2Y.
Can you tell me why you started to multiply that way? Like, why did you multiply them like that?
Because I knew that each basket counts for a different amount of points. So I knew that each X had to count as 3, but each Y had to count as 2 points.
Ah, okay. Snap it up, please. I set mine up kind of similarly, and so I wanted to, unless you did it exactly like Mike did, I want you to take out these notes here, because this is kind of a process of the way we can consider this. So X would be the number of 2-point baskets, and Y could be the number of 3-point baskets. And so this is like, so kind of like you said, Mike, you know that the X's are 2 points. What it gives you is the total number of points, right? How many points, y'all, are the question that were scored in that game? 97, awesome. So we know that it has to equal 97. And so we know that 2 would be 2 points times the number of 2-point baskets. And then we know that, just like you said, I think the only difference between me and you, Mike, is I made my Y for the 3s and my X for the 2s. So that would be one way you can set it up. But there's another piece of the puzzle that they give us, and that is that how many 3-point baskets were made? 11. Excellent. So Y equals 11. So this is not exactly to the level of the systems that we're going to be doing, but I wanted to show you there was a method behind Mike's procedure or his system in finding these systems of equations. So actually what you would do is, since Y is 11, he substituted it in. So he went 2x plus 3, 11 equals 97. And so what he got was 2x plus 33 equals 97. What do we have to do to isolate the 2x? Subtract the 33. Watch your signs. What's 97 minus 33? 64. 2x equals 64. Divide each side by 2. X equals what, everybody? 32. And so we already know y. Now here's the thing. What is an ordered pair? What does an ordered pair have to start with? X or y? X. So what's our x? 32. What's our y? 11. The ordered pair is 32, comma, 11. So the work would look something like this. We got to be the 32, comma, 11. Now, can you do the third? The third gets a little more complex because they're not just giving you the number of 3-pointers. You actually have to figure that out yourself. So now what I want you to do is jump down to question number 3. And we're going to use the 1, 2, 4 all protocol. So you're going to take 1 minute just to try to figure it out by yourself. Then we'll take 2 minutes to talk to a partner. And we'll have 4 minutes to talk to a collaborative group. So go ahead and take 1 minute and just silently and independently see what you can do on your own. All right. Cut. So that's the model lesson. This is my rehearsal. Thank you all for being math participants in my part of the model lesson. Now I want to kick it over to our facilitator to explain how this process works and guide us through. So this is the end of one model. This is me pretending to be a math teacher in front of my colleagues who are pretending to be students. So go ahead. Now I'm going to come back to being the teacher, but Ms. Collins is our facilitator, and everyone else in the class is now part of this PLC group. And let me get you your mic, Ms. Collins.